All right, welcome to this brand new tutorial series. What we're going to be doing is building our own programming language from scratch, utilizing Python and LLVM Lite, which is a bindings library for the LLVM compiler architecture. We're going to be using Python just for the ease of use and more beginner friendly, but as you can see, we're not just going to build a basic toy language that every other tutorial in the world wants to do with this. We're going to start out by building basically a calculator language that has statements and expressions, and we're going to build our language on top of that just to fully signify how languages are built. And we're not going to start out the gate with variables, functions, everything else like that, because I know from experience that is a lot to take in at once, and we're going to go through this the right way. So the first thing you're going to need is Miniconda or Anaconda. Either one, I prefer Miniconda. It just has a lot less dependencies that go along with it. This is just a Python environment manager, and we are using Conda specifically because LLVM Lite installs extremely easily when you have a Conda environment. So I will leave this link in the description for you guys to click and download the latest Miniconda version. If you have an older version, please do update that to the latest or uninstall that and re-download this one. Alright, so the language we are building is called Lime. It's going to be a statically typed and JIT compiled language. It's going to be built in Python and LLVM. Some of the features, we're going to have conditional statements, so if else, or else if else, while for loops, all of the arithmetic operators, mutable and constant variables. We're going to have classes, class methods, properties, and then we're also going to have inheritance of classes, functions, function scopes, as well with variables. We're going to have import statements, built-in functions, a basic standard library, and something unique that I haven't seen really before. Please let me know if this exists somewhere else. But we're going to have some syntax interop. So you're going to have two different ways, two different types. You could honestly implement as many different types of syntax as you want, but they're all going to work the exact same. The two examples I'm going to show is we're going to have a Gen Z approved syntax for our language, and we're going to have a regular meta approved syntax for our language. So let's move on to our lexical analysis explanation. All right, let's get into our Lexer class. Before we hop too far into it, I want to explain what this class will be doing. It's going to be doing lexical analysis, which is taking in human readable source code and turning that into something the parser in a computer can better process and understand, such as a list of tokens or a list of objects that describe the source code that we are taking in. So this particular piece is just a variable declaration in JavaScript. We start out with the let token, which has a token type of let, literal value of let. Move on to the variable name, or what we call the identifier in this particular case. Moving on to equals, then 10, which is an integer, and then the semicolon. And then the order of these and how they're presented will be checked by the parser to build out the abstract syntax tree. If stuff is out of order, such as you put the semicolon before the equals sign, there will be a grammar error in that, and our parser will throw an error to let the user know what they have done and how to fix it. So let's move on to the class and get that started. All right, moving into the code portion, I just have a folder. You can create whatever folder you want. I'm going to segment these out into episodes, so this is just my episode 1 folder. We're going to cd into wherever your project's going to be held. And first things first, we're going to create our Miniconda environment. So that'll be conda create -- name. Name it whatever you want. I'm just going to name it Lime. And then we're going to set our Python equals to 3.12. That is going to be our Python version we'll use today. So while this just kind of installs and gets set up. All right, now that this is done, the activation command is conda activate your env name. So conda activate Lime in my case. So this will then change from base to Lime. And that's how you know your environment's activated and you're ready to start coding in Python if you don't already know that. So the first file we're going to do is our main file. This is where our main code execution is going to start from. And then, so we can start off with if underscore name equals underscore main underscore main. So we'll add a pass in there just so we can say it's set up. Next file we'll need to create is token.py. And this is where we're going to start to create our token class. So in our token.py file, we need a couple imports from enum, import enum, and then we're going to need from typing, import any. So the typing parts is completely optional. I just like to use it. It just adds a little more developer friendliness to Python programming. So you can signify the types. Definitely not needed, just makes IntelliSense a lot better. So the first thing we're going to make is our token type class, which in Python, this is how you create an enum. Just create a class and inherit from enum. And every one of our token types is going to go into this enum. So the first set of tokens are going to be special ones, so special tokens. This is the EOF token, or the end of file. We're going to have an illegal token. Basically is how we throw a Lexer error. The next thing, we're going to need our data types. And the only data types we're going to be concerned with right now is integers and floats. So int equals int, float equals float. Now, since we're starting off with the foundation of an arithmetic language, so it's basically a calculator language, that's all the data types we're going to need. And as we add more, we'll add string in here later. And any other booleans, anything like that, we'll just add right here. So the next set of tokens will be arithmetics. These are arithmetic symbols. We have plus equals plus, minus equals minus, asterisk. You can also name this multiply, doesn't matter. That's just basically this symbol right here, the star. That's how we're going to signify that we're trying to multiply something. Slash, you can also do divide if you wanted to. And that's just the normal divide symbol in any other language. We're going to support pow, so getting the power of a number. You can square a number, just exponents in general. And then we'll add the modulus operator, which you could name this percent if you wanted to. It's all up. Everything's up to you when you're creating your own language. So last but not least, we're going to add our symbols. So first one's going to be a semicolon. In this language, we're going to signify the end of statements with semicolons. Now you can omit this if you don't want to end with semicolons. If you care about just using new lines, up to you. But for this purpose, we're going to use semicolons. So we'll make this semicolon. We'll add a left parentheses, so L paren, and then right paren. So now this is all the token types that we're going to need to start off with our Lexer. So the first thing we're going to create is the actual class for the token. Then we'll add a init method. So what this constructor is going to take in when a token is created, it's going to take in a type, which is going to be the type of token type. This is where I was talking about signifying like typing annotations to your Python. This is definitely not needed, but it helps a lot with IntelliSense, so I like to use it everywhere I can. So we're going to have tokens have a token type. They also have a literal, so it's their literal value. So a number integer token, the value would be 10. If a plus token, the value would be literally just the plus sign. So we're going to say any here. So it can be any. It could be a string, number, boolean, anything like that. So we're also going to take into account the line number, which will be an int, and the position it is in the file. So the character position, what index is it at in the file. I won't type this out just to save a little time, but it's just self.type equals type, self.literal, self.line number, and position. The next two, we just for debugging sake, we're going to implement two methods on token, which is the double underscore string method. Whatever we put in here is what the string will turn into, pretty much what it will print. So we'll make an f string, and you can format this however you'd like, but I will start off with a self.type space self.literal space. We're gonna do the line numbers, so line self.line number, then space position, and we'll do self.position. You can format this however you'd like. This is just how I have it. And now the represent method, the repr, if I could type, is just going to return the string version of self. That's our token class. That's really all we'll need to do for a long time in tokens. When we add some better error handling way down the line, we will modify this token class to give us a little more information. But the next thing that we have to do now is we're going to move into our Lexer class. So we'll create a new file, lexer.py. So we'll go into the Lexer file now. There's a couple of imports that we'll need to do to set this up. So from token, import token and token type. And then from typing, we'll import any. So we'll create our Lexer class. In our constructor or init method, we are going to take in our source, which is just the stringified version of whatever file we're trying to compile and run. So this is our actual source code. So we'll set self.source equals source. A couple more things. The Lexer needs a position field. We're going to set that to -1 at the start, and that will explain this a little bit later on into our Lexer. We have a read position, which is basically one ahead, always going to be one ahead of the Lexer's position. It's just going to keep track, hey, what token, what letter, what character, whatever, what is next. So we'll move down. We have that line number that we need to keep track of for the tokens. So we'll take that. One of the most important ones, which is the current char, or the current character. This could either be a string or none. And we'll just set it as a default to none. And then at the very end of this constructor, we're going to call a method we're about to create called readChar. And that's kind of our Lexer advanced function that's going to trigger our Lexer to add one to these positions, and the current char will be updated to the next one in the string, the source code pretty much. So another thing, these double underscores I'm adding in front of function names just creates a quote-unquote private method in Python, so it will not show up in the IntelliSense. Don't have to do that, just something that I like to do for kind of just makes it a little cleaner. So we'll add our readChar method. Take in self. This won't return anything. It'll be like a void method. So the first thing is we're going to check if the read position is greater than the length of the actual source code. So if self.read position greater than equal the length of the source code. If so, that means we are pretty much at the end of the file. We are done. So we're going to set our current character to none. If it's not, we're actually going to set our current character to the read position in that string, the index. That'll set our current character. And then we need to set our position to what the read position is, and then we need to increment our read position plus equals 1. Now this is going to be a public method that the parser will call. It's our main execution method. The parser will call this to grab our next token. So this does not return a list of tokens. This returns a token. So at the very start, we're gonna just set this initial token variable to none. This is what we'll end up returning. What we need to do is skip our whitespace. So this will be another function we will be implementing. So this skips all of our ignored characters, such as new lines. We don't care about those. We don't care about spaces. We don't care about tabs. So we're going to skip those because we don't need to read them as tokens. So we'll move to skip whitespace. Skip whitespace. Self and none. So while the self.current character is in this list, so a space, we'll do \t is tab, \n is a new line, and \r I'm not exactly sure, but it does show up. So the first thing we're gonna do, this is where we're also gonna keep track of our line number. So if the self.current character is a new line, we're just gonna increment, forgot that. We're gonna increment the line number by 1. And then we're just gonna read another character from the list. And this is gonna keep going until this current character is not one of these. And once it is, we're back to our next token function. The next thing we're gonna use is something, this is why we needed to Python 3.10 or above. We're using a match statement, so which is just a switch case in Python. So self.current characters, we're gonna match that. We're gonna make the case if it's a plus symbol. We're gonna set our token equal to this helper function we'll create in a second. So next, or new token, I'm sorry. And that will be a token type dot plus from our enum that we created earlier. And self.current character will be the literal. So now let's create this new token function, just put it up here. So def __ new token self. We'll take in a TT or a token type, and we'll give it a literal as well, which is a type of any. And this returns back a token. So we'll return, we'll initialize a new instance of token. We'll set the type to TT, the literal to literal, the line number to our self.line number that's kept track in our class, and the position, we'll set that to our self.position. So that's all it's going to do, just so we don't have to keep writing out this line number and position. We're just going to have a helper function to help us out with that. So here is all we need for that. Now for all of these tokens, so we need one for plus, minus, multiply, divide, pow, and or exponents and modulus. So we'll create all of these. Easiest way, just copy, paste. So that's minus, multiply, divide, exponent, modulus. So we'll just go one by one in here. Multiply and divide. The power will be the caret symbol, and modulus is the percent. And then we'll change all of these to their correct token types. So asterisk, slash, pow, modulus. Now there's 2 more specific tokens that we need to handle. Or 3 more. Actually, we need our semicolon, left parentheses, and right parentheses, and then we'll handle these tokens as well. We'll add another, I'll just keep, that was still on my clipboard, so we'll add a left parentheses, L paren. We'll add a right parentheses, R paren. Now, this for the end of file token, that means once this current character is none, so when we set that thing to none right here, that is when we need to handle a end of file token. So talk equals self dot new token, token type dot end of file. and we'll just set an empty string as the literal value. Now the default case in Python for match statements is the underscore. So if none of these, if the current character is none of these, we're going to check numbers now. So if it's none of these, let's see if it's a number. So self dot, another helper function we're going to make is digit. And we'll pass in the self dot current character into that. And we'll go ahead and write these out before we actually define these functions. So the token will equal another helper function called self.readNumber, and we'll return that early. If it's not a number, we want to go ahead and we're basically going to say, all right, if it's none of these options, then obviously it's an illegal token and we don't handle that, so we need to throw a Lexer error. So we're going to set our token equal to our new token function. Token type will be illegal, and the self.current character will be our literal. Now we'll go to the same level as this match statement. After the match statement, we'll go ahead and read a new character and return the token. So this just sets it up for the next time next token is called, and then we return that token back out of the Lexer. Go ahead and implement these two functions, isDigit and readNumber. So we'll go back under here, def underscore underscore isDigit self, and we are taking in a character for this. So we'll just name it ch, and this will return a boolean. So there's some weird syntax here, but return 0 as a string is less than or equal to our character, and our character is less than or equal to 9. So if both these are true, it is a digit. If not, then it is not a digit, and it'll move on to our else statement pretty much. So now that we have this implemented, we're going to have our readNumber function now. So we'll add that down here, readNumber self, and then this won't take in anything at all. This will return back a token. This is where it's going to turn back our integer or our float token. So we're going to do a little bit of logic here. Right now we're going to start with we're going to save our start position, self.position. We have our dot count, so this is just going to keep track, like if it's a decimal, this is how many decimals it has. And that's how we throw an error if there are too many dots in a number. We're going to have our output string here. We're going to set to an empty string. And then we'll do a while self dot underscore underscore isDigit self dot current char. So while this is still a number, or the self dot current character is equal to a period, so that's for our decimal. So inside this while loop, we'll first check if the current character is a dot. So self dot current character equals dot. We'll increment that dot count variable. Next, we'll check to see if the dot count is greater than 1. If it is, that is definitely not a number that we support at this time. So we need to pretty much just print, for now, we'll print an error, too many decimals in number on line, self.line number, position, self.position. And then we will return self.new token. It'll be an illegal token. And we'll just set the literal to the source from the start position to the position we're currently at now. So that'll put that whole number and where we found that extra period as the literal value. So moving on, if we don't have too many dots, we're gonna append the character that we're currently on, self.position, to the output. We're going to read another char, so that advances our position variables. And then if the self.currentChar is none, so if we're just so happen to be at a number that's at the very end of the file, we're going to go ahead and break out of this loop. So once these conditions haven't been met and the while loop breaks, we should have an output string that builds up our number. So if .count equals 0, that means this doesn't have a decimal, so it's obviously an integer. We are going to return, using our new token function, a token type of integer, and then we are going to convert our output string to an integer using this int function that's built in with Python. And else, so that means we do have a dot. We return the same thing, new token, except the token type will be a float, and the float function for our output to convert that to a float. And that's our read number function. So moving on, I think we're ready to test this out. So we can go back into our main.py file. First things first, let's import our Lexer. So from Lexer, import Lexer. We'll grab that class. We're going to set just a temporary debug flag. So Lexer debug, type boolean will be true. That's just going to gatekeep our printing and our running of the Lexer for later. First thing we're going to do is we're going to read from an input file. So with open, we'll put it in a test directory, test/lexer.lime. You can name this whatever the heck you want, whatever file extension you're doing, as f. And our code will be a string, and we'll do f.read. And that's going to convert everything that's in this lexer.lime file into a string. So with that being our source code, we'll check our debug flag. So if we set this to true, we can set up our Lexer. So debug lex equals Lexer, and our source variable will equal our code. So right here, so source equals code, so that's funny. So while our debug lex.current character is not none, just for checking sake, we're going to print the token. So we're going to call our next token function. And us printing this will call our string and represent methods, and that's what we should see for each token. So last thing to tie this all together, we're going to make a new folder. We'll name it tests. Create a file in that folder. We'll name it lexer.lime. Right, we'll just do a 5 + 5 for right now. We'll add a semicolon for funsies. Did we implement a semicolon? No, we didn't. Okay, well, let's go back. I don't know if you guys caught that beforehand, but if you did, good job. Self.newToken, token type dot semicolon, and then we'll put the current char in there. All right, so we almost saw an error, which I guess we should look. So let's not implement this, and let's look at what an error will show, what an illegal token. So Python main.py to run this. So we have a integer 5 on line 1, position 1, plus, and then we have another integer 5, and then here's our illegal token with our semicolon on line 1, position 5. So that's right there. So we'll go back, we'll implement that back, run it again, and now this turns into a semicolon. Everything's good. So we'll check everything that we have implemented so far. So 5 + 5 times 2 minus 3 divided by 4, exponent 69, nice, modulus 10, semicolon. So this should be everything that we have implemented into the Lexer. So left paren, int plus int, right paren, asterisk. Yep, nothing illegal, nothing good, nothing bad, has all of our literal values. So as of right now, we have finished up our Lexer for this first part of the series, creating our arithmetic foundation of our language. play around with that. If you have any more tokens you want to go ahead and add off the top of your head, go ahead and try to implement that yourself. But I will see you in the next episode where we'll take care of the parser and link that up to our Lexer.